Okay, guys, let's solve this. So m is the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the unit digits of m? Okay, so let's look at the unit digits of square numbers. So we have 1, 2, 1, 4, 9, 6, 16, 5 for 25, uh, 6 for 36, 9 for 49, what else? 9 for 49, 4 for 64, 1 for 81, 0 for 100, 1 for 121, 4 for 144, 9 for 300, 139. Okay, so this is the cycle. So can m be, if you're just looking at the units digits, n can be any of these, because all of these are unit digits of, wait, is there every number here? No, 3 isn't here. 1, there's no 2, 3, 4, 5, 6, 7. There's no 2, 3, and 7. Interesting. um, okay, so how do I solve this? Well, there's clearly a bound, because m is the greatest integer. So it can't just be any, like, there are multiple solutions, but there aren't infinite solutions. Hmm. How am I supposed to do this? Well, okay, if it were just this and this is a perfect square, then m plus 1213 equals a square has infinite solutions equals p squared. This has infinite solutions. Now, this has a finite number of solutions. How do we get this? Okay, let's see. So, if we get 1, 2, 1, 3 is equal to, is 1, 2, 1, 3, is that like a multiple of 1, 3? No. No, it doesn't. So what I'll do is I'll isolate so n is equal to p1 squared minus 1, 2, 1, 3. M is equal to p2 squared minus 3, 7, 7, 3. So then setting these equal to each other, we have p1 squared minus, minus 1, 2, 1, 3 is equal to p2 squared minus 3, 7, 7, 3. Now simplify p1 squared minus p2 squared is equal to, difference of two squares is equal to, add this, we get 2560, negative 2560, I think. right? Because 0, 6, yeah. Okay, now P1 minus P2 times P1 plus P2 is equal to negative 2560. Okay, so this needs to be negative. Since these two are positive, that can't be the negative part. This has to be the negative part, which means that P2 is greater than P1, which, of course, makes sense. I don't even know why I had to write that, but anyways. So we know that the perfect, these aren't the perfect squares. These are what is squared to make the perfect squares. The perfect square 1 minus the perfect square 2 is equal to this. Why don't I make everything negative and do perfect square 2 squared minus perfect square 1 squared. Perfect integer 2560. And then do it. So we have P2 minus P1 times P2 plus P1. So just find two perfect squares that when subtracted lead to this. Okay. I feel like it'd be more, I was gonna say just replace these two and put them in here, but that just equals 2560 is equal to 2560, so that wouldn't work. So two perfect squares that when you take one subtracted by the other and take them added together equals this. So that means that, well, of course, since it's an integer, these are integers, that this minus this is going to be positive and that this minus this is going to be an integer. So this is less than, and since they aren't consecutive, this isn't 1. Okay, we're getting somewhere now. That these integers are less than 2560. Yeah. Sorry guys, I'll be right back to finish this. I gotta go eat. Yeah, I'll be back. Okay. So while I was eating, I was thinking. And I was thinking we could probably get a lower bound for this by just taking m equals 1 and plugging this in here and taking the square root. So we get 1, 2, 1, 4. Square root of 1, 2, 1, 4. So we can, well, this thing, 30 squared is 900. So 40 squared is, yeah, so it's gonna be like 30, I'm gonna guess 35. Let's test that. Plus 25, 300, and 900. Oh yeah, it was just about 35. So it's around equal to 34.9. And the square root of 3774. So we know that 25, it's gonna be like 61. Would be 1, 120, 3600, which would be 1273. Yeah, so it's about 61, 61.2, I'd say. So, okay. We know that P1 and P2 are at least these two numbers. So we have Okay. Oh, I just had an idea. We know that these are integers, so they must be factors of 2560. So 2560 is 10 and 256, which is, what is that? 2 to the, oh my gosh. 2 to the 6 is 64, 2 to the 7 is 128, 2 to the 8. And this is 2 times 5. So we have 2 to the 9 times 5. So that means that these must be some combination of 9 2's and a 5. Okay, that's something. Gosh, that 5 really messes it up. Because if it weren't for the 5, then we could just... I mean, it still would be very difficult to do it. Ooh, I found something. P1, P2? Never mind. A good thing to notice is that these both have the same units digit, which means that when these are added together, they both will have the same units digit. Which means... I don't know what that means. Well, okay, I spent enough time on this. I really don't know how to do this. I'm just going to look at the answer and then we'll go through it together. Why don't I guess something though? I'll guess. Which one is the most? 9, 9, 4, 4. Okay, so I'm between 6 and 1. Oh, and 8 is pretty. I'll do 8. Oh, I forgot the website's down. What is it? AMC. Okay, yeah. This is the website with it. This, yeah, AMC 28, 24. Solution for number 9 is... Oh, it is 8. I got that right. Suppose... Okay, so they went about the same way. They factored p squared minus p1 squared minus p2 squared practically. Then they found the prime factorization of 2520 or 2560. Um, so what they did is they found that it said that one of them must be 5 times 2 to the I, and the other is 2 to the 9 minus I. And then they solved for like P1 or P2. Then they just found the maximum of P1 or P2, which is the same as the maximum of K. So I got this, but it's like, I guessed it. So yeah. Anyways, I don't think I would have gotten this one. But thank you guys for watching. I'll see you guys tomorrow. Good. Oh, it's day 200. I forgot. Yeah. Thank you guys. It's been going on for 200 days. I'm very proud of myself. Thank you guys for all your support, by the way. It's really been growing recently. Um, yeah. It's day 200. Yay. Thank you guys for watching. Here's to another 200 days. See you guys tomorrow. Goodbye.